folder and download this file first. It's starting up. At the same time, you have to open the collision and momentum. Let me download this one. The file is right here. I'm minimizing this one. And the second thing you have to do is open this collision lab, the fate animation. So you just skip it and open this one. If it is not allowing to add up, then what you have to do is just attempt to view the simulation average and then click this one and allow once. And this is in the Internet Explorer. I prefer to do in Google Chrome. So what I'm going to do is just copy and paste it here. The same thing. So now you see I got it here. So it if you're using the Internet Explorer, I would say use the Google Chrome. That's better. Now put your name here, your date, and I would say the University Physics 1 here. All the instructions are given right here. This is the formula for the elastic collision. The m is the mass, the v is the velocity, the initial velocity before collision, and this is after the collision. And you have to fill all the tables here. So let's first start with this table, and this is pretty simple to answer. Number one, what defines a collision as being elastic? How do you define the elastic collision? So the answer, whenever you write the answer, use the red one. In elastic collision, both momentum and energy are conserved. Both momentum and energy are conserved. That is called the elastic collision. And then now you have to simulate all this table. I'm going to show you one. The mass is 2 gram, 2r, 2 kilograms. So go here. Let's set this one as a 2 kilogram. Set this as a 2 kilogram. All right. And the velocity for this one is 1.5 meter per second for m1. So I'm just going to set this velocity 1.5 meter per second. This position here, it doesn't matter where your position is. Okay. And now if you come here, the total momentum, this is the total momentum, which is 0. So the total momentum is 0 only when this one has the opposite velocity, 1.5. All right. And what you have to find it out, v1 and v2. So what I'm going to do is just put the momentum vectors. Oh, sorry, the velocity vectors is already given. If you like, prefer the sound, and this is 100% elastic because this one is saying for the elastic collision, which is 100% elastic. All right, now let's start the simulation now. I'm going to pause this one. Okay, so what you see now, the velocity of this one is now reversed. This one is now moving at negative 1.5, and this one is moving at positive 1.5. So the velocity is flipped. The magnitude is the same, but the sign has been now opposite. So this velocity, we set it at 1.5. I'm just going to make it a red, and this is meter per second, and this velocity is now negative 1.5 meter per second, and this is 1.5 meter per second, and make it red. All right. Okay, this is it. And the same thing you have to do for all the values here. Sometimes you might have to use the table. And now just let me give you a little bit hint on this one. For this one, the mass is 6 kilogram. What are you going to do now? So reset everything. This mass is 6 kilogram. Put this one as a 6 kilogram. The second mass is not known. The velocity is 2 meter per second. Come here and make this velocity as a 2 meter per second. I can move this further. Okay, and this velocity is negative 1 meter per second. And this velocity is negative 1 meter per second. You do not know the mass right now, so you just have to calculate. But the total momentum is given 8 kilogram. Okay, so you see the momentum, this is the total momentum, and you know the momentum of the first particle is 12, and this is 1, the negative 1. In order to make it 8, it has to be the 4 kilogram. Got it now? So how do I come up with this idea? So you see the total momentum has to be 8 kilogram. So the total momentum of the first particle is 12. 6 times 2 is 12, mass times velocity, and we have to get it 8. So this one mass has to be 4 kilogram. All right, so now simulate these things. Now all the values are showing here. The mass is now the 4 kilogram. This mass is 4 kilogram. Okay, you see, and I can also get it here, the momentum. So you see the momentum is 12 and this is 4, so the total momentum is 8 now. And now I'm going to play this one. So after the collision, what I see, this one is moving at negative 4 and this one is moving at 2.6. This one is negative 0.4. Oh, negative 0.4 meter per second, make it red. And the second one is moving with 2.60. The velocity is a positive velocity, 2.60 meter per second. All right, now I completed this table. Now the same way you have to complete the trial 2 and 3. And what does it say now? Two objects with the same mass, for example here, the two objects with the same mass move towards each other with the same speed. It is moving towards each other with the same speed and experience an elastic collision. This is an elastic collision too. Compare the final velocity of each object. What happens after the collision? You see, after the collision, the velocity is now reversed. So the magnitude is the same, but the direction is now reversed. So you have to answer right here. And now, a less massive moving object has an elastic collision with a more massive object that is not moving. Compare the initial velocity. So what you have to do, you have to make it let me reset everything here. So it says a less massive object. I'm just putting this a point, or let's say 1 kilogram, and I'm making it a 100 kilogram. Okay, and now let's say this is 1 meter per second. What happens now? Let me run the simulation. Okay, so you see this is a much smaller mass than compared to this one. So after the collision, its velocity is now negative 0.98. So it's almost the same. The velocity, the magnitude of the velocity is almost the same of the smaller mass, but now it is moving back. This is like when you hit a ball onto a wall. The wall does not move, but the ball moves in the opposite direction. That's exactly the case here. So what are you going to write here? So what are you going to write? When a less massive object hits a more massive object, the more massive object does not move at all, and the less massive object moves in the opposite direction with the same velocity. So its initial velocity is exactly the same, or the initial speed is exactly the same as the final speed, but the direction is opposite. That's what you have to write. Now let's go to the inelastic collision. This is a perfect inelastic collision situation. Here you have the masses. After the collision, stick to each other and start moving with the same velocity. So what defines a collision as being inelastic? Only momentum. Only momentum is conserved, not the kinetic energy. And the kinetic is not conserved. That's the definition of inelastic collision. Now you have to simulate all these parameters now. For some reason it's not showing up here. Let me okay. Now you have to fill out these things for the inelastic collision. So what are you going to set it here? Okay, so come here and I can hit this button here. Now you have to make it from elastic to inelastic collision. Alright, and do exactly the same thing as you did it for the first time. In this case, the mass is again 2 kilograms. So just set it, come here and set this as a 2 kilogram. This is a 2 kilogram, and the velocity is 1.5. The velocity, this is the velocity which I'm setting as a 1.5. Okay, and this velocity is 0. So I'm just set here. This is a 0, already 0. And now we have to run the simulation and find v1 and v2. So now, okay, I'm stopping here. So this is the velocity for both objects. Now it just shows the values here too. Is 0.75. So they start moving together. What if you come here on right here, 0.75 meter per second, and I'm going to make this as a red. All right, and what is the total momentum now? The total momentum, let's see here. The momentum before collision and after. So this is the before collision, or after collision. It has to be the same because the momentum is always conserved. So the momentum of this particle is 1.5 and 1.5. So the total momentum is 3 kilogram meter per second. That's it. Just put a dot here. And make it red. That's it. That's all you have to do it. And then similarly you have to fill all these tables here, and you have to write down, just do this one, just repeat this one. This is for the elastic collision, and you have to do this one for the inelastic collision. All right, what is said now for number 10? So mathematically the total momentum before the collision in trial 1 is conserved after the collision. So you just have to calculate what was the initial momentum. So how do you do that? So just you have to, and the way you do that is first out the initial momentum before collision, which is equal to the mass times velocity of both objects. Or what I can do is write down m1 v1 plus m2 times v2. Just calculate this value now. m1 v1 plus m2 v2. Come here for, you know, m1, you know v1, you know m2, you already calculated v2. Just plug in all this value, and the same way you calculate the final momentum. Exactly the same thing. Control C and Control V here, and this is the final momentum after collision. Final momentum after collision. Calculate the same thing. These two numbers has to be exactly equal. All right. So this is a pretty simple experiment. In this simulation, you learn see how the collision works elastic collision and inelastic collision, a perfect elastic collision and perfect inelastic collision, and the simulation gives you an idea, the direction, the magnitude of the momentum after the collision and before the collision. All right, just fill in this table, and once you have completed, save this one, go here onto the blackboard, and then you can submit this one right here, and then attach the file right here, write your submission. Once you do that, that's it. And if you have any questions, please write to me. Thank you so much. Bye bye.